Good evening, everybody, and welcome to ML Ticket. And we are now doing a revision of the project that we have done. Uh, what we have done, we have addressed a regression problem, and it's a beginner project, and we have solved it. Okay, and we have learned many things on the way. Many every step, how to do things, how not to do things, what to do, what not to do, many things, and I also gave you the scope to learn more. I always tend to say that do not trust the code because the code is very volatile, but if you know uh, what you're doing, if you know what has to be done, then you can easily find the code, or you can write the code on your own. It won't be a mess if you understand everything. So let's get started with today. Give me a moment. Okay, just a minute. Let me just. Okay, so what happened? Okay, that's not a problem, I guess. So yesterday we learned till, I guess we revised till missing values, if I am not wrong. And today we are going to start with categorical values. I'm again repeating this. I will be repeating this one more time in the next session, that our machine learning projects can be roughly divided into three parts. That is data visualization, data pre-processing, and implementation of machine learning algorithms. And right now we have revised data visualization. To be honest, there is no limit to learn data visualization. There are so many things that you can learn about visualization, that it is not possible for anybody to cover anything and everything that is on earth. So you must keep on learning, keep on exploring, and eventually you will understand the vastness of the sea that you are in right now. So we have started with the pre-processing. We have in the beginners project, in this particular project, we have covered some of the most basic pre-processing that needs to be done in the dataset, and we have chosen a dataset which contains almost every kind of possible possible pre-processing problems, and not all pre-processing problems, but most of them, most the major ones. Okay, so handling categorical values is another pre-processing problem that we need to discuss. As we said, Jay, if I start speaking to you in a language that you don't understand, okay, so you will be having trouble to communicate with me, or to comprehend what I am saying. So that's a problem, okay. And when I am giving you some informations in a language or in a way that you won't understand, then it's very difficult for you to pick up on things. That's why it is very important for you to get familiar with the language in which the instructions are now given in. In a similar way, we are now giving instructions to the model, right? And since we are giving instructions to the model, it has to be in terms of numbers. Okay, it does not. Our model at this point when you are at the beginner stage of the regression and addressing a regression problem, our model is not smart enough to understand words. Okay, it is not smart enough to understand a letter or anything alphabet. Okay, it is not smart enough. It only understand numbers. So we need to find a way to convert our observations, or everything that we have done, into a number. Okay, so yeah, okay, let's let's see. Okay, so we have discussed about the types of categorical values. You can read through the PPT when it's on screen, but I am going to just explain you the mere basics of it. That the categorical values can be divided into three major parts. One is ordinal encoding, another one is one-hot encoding, and another last one is dummy encoding. Okay, and we have covered everything in detail, and we have also read a little bit of theory on ordinal, nominal encodings and all. And I also showed you an example, if you remember. Let me get back to that code so that it's easy for you to understand. Hmm. Yeah, this one. Uh, So we saw the using ordinal encoding, it turns the string into a number, and it's a whole number. And to be honest, as we discussed, as we went by, we talked about that some machine learning algorithms like these categorical values to be divided into binary formats. There is only zeros and ones. When it understands this better, it absorbs the data better when the data is in binary format. So we use one hot encoding to convert the same data into some kind of zero combination of zeros and ones, so that some unique combinations of zeros and ones, so that our model could easily understand this particular thing. Another thing that we touched upon is that if we drop one of those columns, which is one of those columns of the zeros and ones, which is created by the one hot encoder, it won't affect anything. It won't be affecting anything. Rather, we will be saving a bit of data. And now you may argue, we are saving a very less amount of data. Like not adding one number is like saving one bit. Okay, and one bit is very small. Okay, it's a very small. But again, I want to remind you that of the fact that a bit becomes very large if it is multiplied by a huge number. Okay. um, Okay, so if you are considering a data set of 2 million or 4 million data points, now that bit value becomes a considerable amount of data. Okay, considerable amount. It will take up unnecessary CPU computations. And if I talk in the language of operating system or a little technical language, it will be overhead for the CPU. Okay, so we have not done this. To be honest, I have not used drop functionality in one encoder. If you go through my code, you will definitely see that I have not used drop functionality. But I would like you to use this particular functionality and see that what improvements that you can get over the accuracy score that we have right now. Okay, so I hope that you can understand till now. Let me just talk a little bit about categorical values. Almost everything that you come across have a categorical values. Like are if you go for a classification problem, like if you go for the Titanic datasets, it is a very good dataset for classification problem, to where to predict whether the person died or not. Okay, so I think there is two variants of the dataset. One in which the death column contains yes or no, or another variant contains the death column contains zero or one. Like zero is dead and one is still living. Okay, one is not dead, alive. So not alive till dead, but alive at that point. Okay, so you can try and test these kind of values. You can fetch data sets which has categorical values and try to convert them using a one hot encoder. And to be honest, in our data set we have only one column which contains string values or object type. or the data type is object, and we only applied this one hot encoding over that column. But if we had multiple columns like this, we would have applied this them to all. So I would like you to go through some of the data sets that you may just find many data sets in Kaggle and all. To be honest, Kaggle is my favorite place to pick up data sets. It contains almost everything with examples, and also it's a very good website, I guess. And so if you pick some data sets and you start working with them with the categorical values, you will slowly understand what is the worth of using one hot encoding. To be honest, at that point you don't need to go for ordinary encoding. You can directly go for one hot encoding or dummy encoding, dummy variable encoding. And yeah, so I just mentioned these things so that the a bigger picture becomes clear for you guys. I don't want to stress upon anything, but most of the code that I have written in is not relevant because I have told, because I was just teaching you the basics. So I was talking about the basics. That's why I had to write a lot more thing that you people expected. So that's okay. I think let's get moving. Okay. So the next thing under pre-processing is feature scaling. So as we have said, if you want to read through the PPT, you can just read through it. But as I have said, you have to eat according to your size. Okay. In the similar way, in our dataset is our dataset contains details of different scales. Mane, some data ranged from 0 to 15, some data range from 0 to 5 lakh, some data range from 0 to 50, some data is ranged from 0 to 1. Okay, so we don't have a exact scale on which every data can be represented. So it is very important for you to bring that down to one particular scale, right? So it's very important for your model to understand, because if you don't do feature scaling, this is when I this is like you will get a less accuracy score, that's all. Okay, but after doing a feature scaling, you will definitely get accuracy score. To be honest, this is a very important thing that acha, let me just go for the types of scaling and then I'll explain. um, the first type of scaling is normalization, that is shifting all the values, whatever value that you have, into a range of 0 to 1. And another is standardization. It does not bound the values to a specific range, which can be a problem for some algorithms. And generally, we use standardization. And hands down, I would say just go for standardization. You don't need to think much about it. Of course, if you want to explore this area, of course, go for it. I won't stop you, but using this scikit-learn standard scaler is the most often done thing that people do. Okay, and another thing that I want to discuss, if you have noticed that I have done this particular feature scaling at the very end of the pre-processing sector, because feature scaling, I would say feature scaling is the last, before pipeline, of course. This is the last step of pre-processing. If you want feature scaling in your project, of course. If you don't want, that's a different scenario. But if you want feature scaling, I would suggest you to go for feature scaling at the very last. Okay, because after you scale your data, if you would yeah, after you scale your data converts into something like this. And to be honest, you as a engineer, or you as a when you are doing the project, you won't be able to understand any kind of recognize any kind of data. Okay, so it will be impossible for you to understand any kind of data, because some data where, I mean, up to now you have seen some data contains only integer values, some data contains float values, some data contains uh, data in a range of 0 to 15. Okay, but now you won't be able to distinguish between them. So if even if you look that upon or look that on a pandas data frame, you won't be able to understand anything. So it is better to do the feature scanning at the very end. Now, let me just get back to the pipeline. To be honest, we when we completed the session, we completed our pipeline. We got to know the full extent of the pipeline, the full power of what pipeline can do. We saw, Jay, we could take any data and pass it through the pipeline and transform the data, I mean, in just like in 1 second. It will apply everything in a linear fashion. Just let me just go through it once again. That is pipeline. It provides a this Python scikit-learn provides pipeline utility to help automate machine learning workflows. Pipeline works by allowing for a linear sequence of data transforms to be chained together, accumulating in a modeling process that can be evaluated. Okay, so basically, what it does, it builds a linear fashion in which our data has to be pre-processed. Like in first we implement imputer to fill out the missing values, then we do function transformations. I have not talked about function transformations because to be honest there is nothing to talk about much. You just make one or two change when I mix up one or two columns and make some new values and see if they are correlated or not. And if you want them, of course, just add them using function transformers. Okay, if you want to get a deeper insight into what this function transformer is, I would like you to go back to the session that we dedicated for function transformers and only to function transformers and custom transformations. So you could get a greater insight. Then we applied standard scalar, and later we used the feature unions, a feature union feature. When in the previous version of sklearn, there was a class which is known as feature union. Okay, and now column transformer is a better class than feature union and does the job. So we use column transformer right now as to punch those numerical values with the categorical values. And to do this everything in a linear fashion, we just need to call the full pipeline dot transform. And if you can get to that code, yeah, if you can see that we have taken some data, some first five data, and just we are just passing the data using transforming the data using the full pipeline variable that we created here. Yeah, this one. And it takes care of everything. Okay, it takes care of everything that we have done, that we have of the all the pre-processing have been done. So we don't need to explicitly do anything up on this, and it could be great for you to go. Another very important for feature of pipeline is that another great feature of pipeline is that uh, when you are going for the accuracy score, right? If you I have actually left a space here, like this add extra feature, right? Add extra features. If you turn this, it is true by default, I guess. If you turn this to false and rerun the code, and you may see a slight change in the accuracy score. Whether it's a bad or it's a good, that depends. Okay, and whether that feature you added or removed has a better correlation or not. So that's a different thing. But what the point that I want to make is, suppose you add another feature, right? Add another feature using this function transformer. You can immediately check the accuracy score. So you don't need to go back to that code and manually add that column and then do all the pre-processing again. No need of doing this. That's the essence of using function transformers. Function transformers help you to automate this stuff so easily. Okay, so you can just check that whether that particular feature is actually giving you a good result or not. Okay, so these things are very useful when you are when you are checking the accuracy score. When I was discussing about the pipeline, I also said that there are many features that I won't be discussing right then. Okay, I never discussed those things at that point, but as we move on. Now you will understand what is the full power, what is the main power of pipeline. Because at that point when we used pipeline, I only described it as a linear way in which you can pre-process the data and you don't need to think about it. But to be honest, you may have argued, Jay, actually I am writing the program in a linear way, right? So everything is from top to bottom, it is combining from top to bottom. So it is also having also having also transforming the data in a linear way. So why use pipeline? So and now if you when you have seen the whole picture, now you can understand the why use pipeline. We could transform any data. We could transform the input data almost instantaneously. We don't need to um, do the hard computations, because we have converted uh, we have pushed the entire pre-processing setup that we have done, entire pre-processing we have done into a single variable, and we can just use the transform method inside it to transform our data. So this is how powerful pipeline is. I would definitely recommend to use pipeline. Okay, there are a few things that I would like you to definitely use. Whether you are doing a beginner's project, intermediate project, that point till you are in supervised learning, definitely go for pipeline. Okay, do not leave pipeline. Pipeline is one of the most essential features if you are going for more than one pre-processing setup. Okay, if you are doing many there are more than many pre-processing that I could have done here, but I have not shown you those because that would have got way more complicated and you would have lost interest. And that's why I just picked up some of the most common pre-processing that we could have done. And this is all about pipeline. To be honest, I think by this time you have realized that how powerful the scikit-learn pipeline feature is. When I first came to know about it, I was literally in shock that how powerful is this thing. Okay, there are some more things, some more libraries in sklearn which acts just like the pipeline. Okay, I won't be talking about those, but some of those work pretty well. I've used some of those and it works good enough. Okay, and each other library in our scikit-learn is dedicated for something new, right? Something extra. Like pipeline is something extra. Okay, so we are done now with pipeline, and to be honest, I don't want to extend much about on this right now, because we have completed pre-processing. Yesterday, I said that for the next yesterday in the previous session, I said that I'll be taking the three more session and will doing a revision on these sessions, and I'll be covering 33% of the entire project in every day so that we can complete in 3 days. And to be honest, we have covered our next 33%, that we have covered 66% of our project, and the only thing that we are left with, I guess, is machine learning algorithms. And to be honest, we can leave that for the tomorrow or the next session, and we can still talk about these things what we have done. Okay, so basically machine learning, let me just close it by saying, end this session by saying that machine learning algorithms is not something which is developing every day. Okay, I can just name a few of the most basic and I would like you to go through them. Uh, until and unless you go through these particular algorithms on your own, you won't be able to understand how powerful it is in which sector. Mane, the most common question that today also I ask myself when I am doing a project, that what algorithm to use, on where and when to use that. Should I use k-nearest neighbor? Should I use linear regression? Should I use decision tree or random forest? Which one to use? Okay, to be honest, this is a problem that I face till date, because I would say, and people also have made thousands of videos on YouTube just answering these questions, but till the moment as I have experienced that the more you practice, the more you go through data sets, the more projects you build make, you will get the clarity. Okay, it is not something that could be taught. It is something which comes from instinct. Okay, you will start to understand what are the do's and don'ts of which of the algorithms that you are using. You will understand the metrics of checking the accuracy score and what to use when, what not to use when. Okay, and as you go, you will get a great insight. At first you will be like blindly checking every algorithm by brute forcing the accuracy score. But as you go through many projects, you will understand that what algorithms to use when you are doing a classification problem, what algorithms to use when you are doing a clustering problem, what algorithms to use when you are doing a deep learning problem, or a unsupervised learning problem, or a supervised learning problem, what algorithm to use when you are doing a univariate regression problem or a multivariate regression problem. Okay, so you will understand as you go. Okay, this is something that I cannot teach you, because to be honest, there is no particular answer to this question, because every day nothing, something new is coming, right? You will learn today this algorithm, tomorrow another algorithm will be generated which works better than this. And how many things that you can buy heart? There is no point in buy heart in these things. You have to just develop your instinct on these things. At the end of the day, the main fear, concept is to develop the instinct that over this project, so that you can just look at the question, you can read the problem statement, and your instinct will tell you that, okay, these are the set of algorithms that you want to use. And if you get that familiarized with these algorithms, you will also the hyperparameters will start popping in your head. You will understand that, okay, I can use I can use these values for the hyperparameters, these values. I can check on these values and pick up the best hyperparameter values among these things. And these will start coming to you. Okay, these are something which you need to go through once or twice. First, at first it will be little hard for you to understand everything, but as you go, you will start feeling the fun. You will get the heck of it. Okay, so let me just the I don't want to pressurize anymore, and I am just closing my session today. And enjoy the rest of your evening, and thank you. uh, we will be meeting tomorrow for the very last session of our ML project, of our ML ticket, and of course the regression problem. So of course, see you guys tomorrow.